Good morning and welcome to AP Statistics. Today we're going to go over the open-ended portion of the Chapter 3 test prep from page 205. First question asks you, 11A, to create a scatter plot. And it's not that hard to do, but just a real quick picture of what it might look like. You can certainly mark whatever increments works for you. I have a break and I'm going from 30 to 60, and then a vertical break, and we have to go from at least 80 to 95, so we'll just say 80, 90, and 100 over here. All we're doing is graphing a quick scatter. So the first point's 36 and 86, give or take, so it's over there. Then we got like a 48 and 90, so round over there. And then it just starts to climb up a little bit. And then we get over here. So more or less, that's a quick sketch of what the scatter plot might look like. Next question asked you, what is the equation of the Lsrl? So the equation is going to be y hat equals 71.95 plus 0.3833x. And again, that's just found using your graphing calculator. We're supposed to then find out the prediction for a 480-month-old person. And we find that's 255.95 centimeters. They give us the conversion for centimeters, so you can divide by the given, and you get about 101 inches tall, which is basically 8'5". That's a pretty tall person. So the question was, why does that seem like an extraordinarily high value? The answer, of course, this is domain limited. We're talking about the first 5 years of a person's life, and your growth is not going to be linear for the rest of your life. Therefore, this is obviously not something you want to put any faith in. It's way outside our domain. Okay, 12A, if you look at the graph they gave you, the coordinate at negative 19.4 and 330, that's way above the prediction on the Lsrl. So it's got a very high residual value. Question is, if it's removed, what's the impact going to be? Well, first thing is, if it's removed, the correlation strength is going to get much stronger because of the limitation in that large variation. So the R value gets better. The slope is going to decrease because that line, which was already somewhat negative, is going to settle into the rest of the coordinates on the graph. So it's going to become a little more negative and stronger. However, and this was the difficult part, the y-intercept is actually going to get higher. Now, there's a good reason for it. If you take a look at the x-axis on this graph, it's all very negative. We are not even remotely close to the origin, okay? So yes, the line is going to bend down more, which we said raises the left end of the line, which would make the y-intercept go up. But that's not where the y-intercept is, because we're all on the negative side. You got to go way far out there to the right to find the y-intercept, and since it's pointing more down now, that's going to continue to be a lower y-intercept. It's going to be more negative. That was a tricky one because, again, we're used to seeing graphs where, since there is a vertical axis on the left side of this picture, we think that is the y-axis. It's not, because we're not even close to it. Moving on to 13, part A. Actually, we didn't finish 13, part B yet. The standard deviation is going to get much smaller because without that excessive value with that huge residual, the average distance to the Lsrl is going to become much smaller. So it's going to shrink the standard deviation. Now we could do 13A. The equation that they want you to come up with, I'm just reading it from the output, but y hat, which is the percent of area burned, equals 92.29 minus 0.05762x, which is the number of wildebeest in the thousands. The meaning of the slope, part B, for every additional 1,000 wildebeest present, 0.05762% less forest is expected to burn. Not that wildebeest prevent forests from burning, but that's the correlation. It's not cause and effect. Part C, they want you to find the R value. Well, the R square is 0.646, so square root it, and you get 0.8037, but this is a negative correlation, as we can clearly see in the graph. So it's negative 0.8037. Remember, you have to look at the data to determine, or look at the slope, the B value, and the output to determine what kind of correlation we're talking about. Somewhat strong, negative, linear correlation. Part D, all you had to do was look at the residual plot, which shows no distinctive pattern, so a linear model is appropriate. Again, obviously, all models have their limitations. This wouldn't continue forever, but on the domain we have, and perhaps a little bit outside of it, we have a reasonable predictor with a linear model. Okay, so that was it for the Chapter 3 overall chapter review. What you have to do now is just study for the Chapter 3 test, which will be on Wednesday next week. And to help you get ready for that, I have posted for you 2 assignments on quizzes.com, which I'm sure you got the invitation to on the Google Classroom, and a lot of you already have logged in and set up your account, which just means you logged in. So starting this morning, there will be one little quiz available to you, and then I believe right at class time, I scheduled the second one to release, which is due on Monday. I don't know, they're kind of a fun alternative to just worksheets and pictures. So do your best on them. You can do them again and again. There's no limitation. If you get things wrong and you want to improve, do them right and get a better grade. For right now, because it's, again, the first time I'm using this site, the fact that you are doing it and putting in the effort will get to 100, but it's always nice to have that, good feeling inside when you've actually genuinely earned a 100%. So see if you can't do that. Any questions or problems, please let me know. Today's meet, you can certainly log into and ask any questions you have. I'll be there to help as per usual. So any questions, just send me an email and I'll help you out. That's all for today. Have a great day and a great weekend.